Hi, my name is Walker Reed, and this is my Physics Lab 5 human rocket. So for an introduction, this lab is based on the free fall of Felix Baumgartner as he reached a top speed of Mach 1.25. The main physics principles used in this lab are Newton's second law, and more specifically, the momentum principle. This states that the acceleration of an object is proportional to the force acting on the object. The high acceleration of Baumgartner during the free fall shows that some other forces besides drag existed. So for his free fall by the numbers, he started around 38,969.4 meters up in the air, and then on his way down, he reached a top speed of Mach 1.25 or 377.1 meters per second. The total free fall was 260 seconds, and the amount of time at his top speed was 50 seconds. The parachute was deployed at about 2,567 meters, and the minimum temperature during the fall was around 202.1 Kelvin, or negative 95.89 degrees Fahrenheit. And then his mass, along with his suit and everything, was 117.934 kilograms. So to find the drag coefficient and kind of calculate for the changing density, the formula used was 1/2 times PV squared times the CDA. When you plug in the numbers from the last slide, you get 0.6437. And to model the change in air density, you must use the formula P is equal to P0 times 273 over T, temperature, times E to the negative P0G H divided by 0. The starting temp and final temp were 248.164 and 271.464 Kelvin, respectively. Delta T, or the change in temperature, is just calculated by subtracting the final temperature minus the starting, and then dividing it by the entire freefall time, which gives the delta T value of 0.0896 Kelvin. So here's the code with all of the values on the last two slides inputted. We initialized his mass, the position that he's at. He started from rest, so the vector is just 0, 0, 0 for velocity. T, the delta T, the change in temperature calculated, the temperature, the minimum temperature, P0, and then the other P0, as well as what the value of E is. We also include gravity and the J hat vector, and then the bottom is our B value for the drag coefficient. So for the actual while loop, it was while the time is less than 260, which is about how long he was falling for. Then you insert the formulas for finding drag and using the force of gravity. And then to get the net force on those, you just add together the gravity and the drag. And then the velocity update and position update formulas from Newton's second law are also there. And then the T's and the temperature have to update with every iteration of the loop. So here are the results. As you see, the position versus time graph, he starts to accelerate, and then it starts to level out as he's possibly hitting terminal velocity. And then his velocity versus time is there, where he starts out and hits a max speed of around 310 meters per second, before then he starts to slow down as he approaches and eventually deploys his parachute. So for conclusion, the program did not completely predict the numbers shown in the actual free fall. The top speed in the predicted generated by the code was only 309 meters per second, whereas the free fall that Baumgartner actually did, he reached a top velocity of 377 meters per second. This could be due to a few things. One possible scenario may be the density of the air. It may not be exactly how it was iterated in the code, or temperatures just being a little bit off. It's also possible that other forces may not have been as prevalent due to the way his suit was made. Maybe air resistance didn't have as big of an impact, and how he was positioned on his way down.